Okay, so we talked about our monoatomic ions. Now I'm going to get into the polyatomic, meaning that we have more than one that we have available. So in this case, you will need your list of ions, and you can either do that online on Classroom, or you can grab one from here in class, however you've done it, or print off your own, doesn't really matter to me. So, first of all, if we see we have Ba, we can go look at our periodic table, find Ba, see that it's in group 2, that's barium, so we have a 2+, and if we go to our polyatomic ion list, we see that CO3 is a 2-. So that makes sense why we have the CO3 2-. So these two together are going to be balanced because 2 and 2 balance out. So that means that we will have barium carbonate, because if we look at our periodic table, we see that Ba is barium, and if we look at our polyatomic ion lists, we see that CO3 2- is going to be carbonate. So when we name it as barium carbonate. Now, Na is sodium. On our periodic table, we know that sodium is in group 1, so that's a plus. So that means that SO4 is going to have a 2- because if we have a plus here, and we know that SO4 is a minus, it has to be a 2- because we have 2 sodiums in our equation. So now we need to go look at our SO4, find it. So SO4 2- is going to be sulfate. So that means that this is going to be sodium sulfate. So remember, 8 means that it's going to be balanced with what it has already. So that means SO4 is its base, or the more oxygens. If it was SO3, then it'd be 8. Now, with that being said, we have to figure that out when we get to here. So if we have magnesium, if we look at our periodic table, we can look and we can see that magnesium is in group 2. So that means it is going to be a 2+. So we have Mg2+ plus our phosphate. And if we go here, we can't see it down here because it's a polyatomic ion. So we got to grab our list of ions. We go to phosphate. We see that it is PO4 3-. So we have to go PO4 3-. So this is where we need the crisscross method, because remember, crisscross means that we're taking this number, we put it down here. So when we create our equation, we have Mg3, and Mg has a 2+, so that means we need to put this down here. So our crisscross equals out, because 2 times 3 is 6, and then 3 times 2 is 6, so these two are going to balance out. That works with our crisscross method. But since we are multiplying the entire polyatomic ion, we have to put parentheses around it and give it a 2. So magnesium phosphate's equation is going to be Mg3 PO4 2. Alright, so let's do one more. So calcium, we go back to our periodic table, we see that calcium is in group 2. So we go Ca2+, nice, that's the same one as magnesium. And then we go sulfate, another polyatomic ion. So we go here, go down, we see sulfate is SO4 2-, sorry, SO4 2-. And the nice thing is these two will balance out. So we can just put Ca, and if you want it, you can do the parentheses. You don't have to do the parentheses. It can just be SO4, or it can be SO4. Either one's fine. If you want to get used to writing the parentheses, I suggest doing the parentheses, because I mean that's how it's written out above to make it easier. All right. And this is what we're going to do on this one. Now remember, the only real polyatomic cation we use is either hydronium or ammonium, which is what we have up here, but ammonium is what is used most often. So, for instance, ammonium might be that one, you never know. Alright, so if you have any questions, please email me. This is all for today. Hopefully you can get the hang of these polyatomic ions, because we'll probably use it for a little bit. Alright.